One GPU replica cannot serve 10,000 users. Beyond its hard ceiling, requests queue and people see timeouts. The fix sounds simple, scale out. But the naive way fails badly. And the reason is pure LLM. Why does one replica saturate? A server like VLLM packs many requests into one forward pass with continuous batching, but that is bounded by GPU memory and finite compute, a hardware limit, not a config. So you put a load balancer in front of n identical replicas, each a full copy of the model on its own GPU. Now the trap. In a normal backend, requests are cheap and roughly equal. So round robin, just rotating and cycling works fine. LLM requests are the opposite. A one-sentence summary is 20 tokens, half a second. A long document is 4,000 tokens, 80 seconds. A 100-to-1 ratio, and round robin is blind to it. Picture the grocery checkout. One cashier gets a cart with 200 items. The next gets 3. One lane backs up while the other sits idle. Under real LLM traffic, P99 with round robin can be 5 to 10 times worse. The fix is the smarter checkout instinct, join the shortest line. That's least outstanding requests. The balancer tracks how many in-flight requests each replica holds and sends each new one to the fewest. A replica finishing its heavy job instantly becomes least loaded and attracts the next arrival. It self-corrects. Now a concern unique to LLMs, KV cache reuse. When a request arrives, the server computes attention keys and values for every prompt token. For a 2000 token system prompt, that's expensive. But modern servers keep a prefix cache. If a new request shares the same leading tokens as a recent one, those values are already in GPU memory and it skips the work. A huge win for long shared prefixes. Here is the catch. That cache lives on one specific replica, send the same system prompt 2 different replicas, and each recomputes 0 benefit. So prefix-aware routing hashes the shared prefix and sends everything with that hash to the same replica where the cache stays warm. Now autoscaling and a mistake that quietly sinks fleets. Do not autoscale on CPU. LLM inference is GPU bound. The CPU is near idle while the GPU is pinned, so your autoscaler never triggers right when you need capacity. The right signal is queue depth, the request's waiting, which rises before latency does. And loading a big model into VRAM takes minutes, so autoscaling can't absorb a sudden burst, which is why you keep a warm spare, a replica loaded and ready. Readiness gates hold traffic back from a replica still loading, while draining lets in-flight generations finish before you remove one. Now autoscaling and a mistake that quietly sinks fleets. Do not autoscale on CPU. LLM inference is GPU bound, the CPU is near idle while the GPU is pinned, so your autoscaler never triggers when you need it. The headline: LLM requests vary 100-fold in cost, so route by load, not by turn. Watch the GPU, not the CPU, and never join the line behind the 200-item cart.